A warm welcome to you, grade 12s, right? So we're going to do revision for trigonometry, which is going to include, or rather, we're going to focus on simplification using reduction formulae, double angles and compound angles. Then we're going to do some trig identities. Then, if time allows, we can look at general solution. So the first question is here, right? A very, very nice question here. From one of the previous papers, right? When we are simplifying, what is the tool that we need to use? What do we need to use, good people? Anyone real quick who can tell me what tool are we using there? What diagram are you using there to ensure that we answer these things correctly? Anyone real quick? Yes, Ms. Ngobile? I'm listening. Okay, she's saying the cast diagram. Thank you so much. Yes, ma'am, that is the tool that we need. We need the cast diagram, right? Which diagram is that? Remember this one here? Right, this one. Whereby we should allow sweet treatment for lighting. But some people, call it all stupid teachers, what. Don't do that, good people, eh? So what you do, write 0 degrees here, and then you write 90 degrees, 180 degrees, 270 degrees, and 360 degrees, okay? 360 degrees. Then what you do is that you're going to put minus here, then you're going to put plus here, okay? Then you're also going to put plus here, then you're going to put minus here. So another thing you can do for 360, you can actually write it as or 360 degrees, okay? Then you have your minus 10 and your plus. Now let's remember that this is quadrant number 1, this is quadrant number 2, right? Quadrant 3, and then we have quadrant 4 there, right? And then now the minus here, it means that in this one we have 360 degrees minus theta, okay? In this one the plus here will mean 180 plus theta, right? So that will be 180 degrees plus theta. You can write it 180 plus theta. Just go into the exam remembering that this one in here, it will be 180 degrees minus theta in quadrant 2. Okay, then we can start. Remember that all of them are positive in here. Only sine is positive, only tan is positive, only cos is positive. You can even sing that. By now you must be singing it, eh? Alright, so the first one, sine 180 degrees minus theta. Your focus should be here. That's the main focus. 180 degrees minus theta. Which quadrant is that, good people? Anyone who can tell us which quadrant real quick? Yes, Tabo. You can unmute your mic there. Okay, people, you don't want to talk to me today. Okay, Tabo says 2, right? That's very, very correct there, right? No, that's very nice. So it means it's quadrant 2 there, right? Don't be scared, good people, eh? No one knows you. Yeah, no one knows. No one will know, right? They will not know. You just talk to me. So that is great. This is second quadrant, eh? Second quadrant. Now in second quadrant, now I need you to focus here. You start on the bracket and then now you focus on here, right? Is sign positive or negative in that quadrant, right? Quadrant 2, is sign positive or negative? Anyone real quick? I think it's still Tabo or
Positive.
Yes, Kiamuchet. Nice stuff. Positive. So it means sign is positive. I'm quickly going to write it as positive sign. Good people, is it correct to write positive sign 180 degrees? And we said sign is positive. Is it correct to write sign 180 degrees? Is it correct? Anyone?
No.
It's not correct. But believe me, there are people who are actually doing this. I've seen in classes that I teach. It's so sad. But then I hope that people actually understand that we are going to then say sine theta. Okay, we're going to say sine theta there. All right, and usually this diagram here, I actually like it in a different format, because now to avoid such things, right, you can actually maybe fill it in. You understand me? What do I mean by that? Fill in all the information on the diagram so that maybe you do not make those mistakes there. So what I mean is that maybe since we're saying all are positive, write it here that you have positive sine theta, you have positive cos theta, you have positive tan theta. Okay, and then in here write it to say it's only positive sine theta, but the rest are negative. So you have negative cos theta, then you have negative tan theta. Okay, so sorry I do not have much space there. And then in this quadrant it's only tan which is positive. Write it tan theta, negative sine theta, negative cos theta, and then in this one here, remember it's only cos theta which is positive, then the rest are negative there, the rest are negative there. Right, so it means that if we are saying this is in the second quadrant, which is in this quadrant, we're going to take the sine theta to say sine theta is positive. All right, no problem. Always also try to use brackets, right? So but I'm just going to write it as sine theta. Yes, someone has a question there. Yes, I'm listening. I think it's Dakalo. Sorry, sir, I can't see your screen. Oh, that's strange. Sorry, let me just quickly reshare the screen, and you can confirm with me if you are able to see. Are you able to see now, or you still can't see? Okay, so we're waiting for your response. We'll continue there, right? So we said that is sine theta, and then cos 90 degrees minus theta. Good people, let's remember that remember you focus in the bracket first, right? Let's remember that 90 minus and 90 plus, those are co-ratios. Okay, that means that if you had cos, it's going to change to sine. If you had sine, it's going to change to cos. That only happens for 90 degrees plus or minus theta. Okay, meaning 90 degrees plus theta and 90 degrees minus theta. So here, because we have cos, that cos is going to change to what? It's going to change to sine. Okay, so you can put it in brackets there, and then you have minus 1 all divided by cos negative theta. What do we do to negative angles? What do we do to negative angles?
Add 360.
We add a 360, right? So that would mean that we say cos into 360 degrees and then minus theta. So we just squeeze in a 360 inside there. Just squeeze in a 360 degrees inside there to recognize that, oh, actually this is in the fourth quadrant. Okay, and then in that quadrant, right, we do know that our cos is positive, right? So we say we have cos theta. Quite nice stuff. Sine theta times sine theta, that will be sine squared theta minus 1. Beautiful. Are we done, good people? Is this the final answer?
No.
Then what can we do? What can we do, man? Anyone to assist us, or do we just agree that that is the final answer? You said no, right?
It's not the final answer.
What can we do, Tabo? Assist us, Bella. Yes? Yeah, Kululego. You can speak. Okay, no, that's fine then. um, so this is not the final answer, good people. Why? Because now you have sine squared theta minus 1, eh? Now when you're at this point, you can remember the following. Ne? A 1, if you can remember in grade 10, we said that sine squared theta plus cos squared theta is equal to 1, if you can remember well. Okay, so that means where I see 1, I am allowed to put this. All right, so because of that, I'm going to say, okay, I have sine squared theta minus, and then inside, remember to use brackets, right? We will have sine squared theta plus cos squared theta, right? All divided by cos theta there, and therefore we shall have sine squared theta minus sine squared theta, and then minus cos squared theta. So it means I'm multiplying by the negative inside. Okay, then from there, that should give us what? That should give us okay, over cos theta. Then these two, they should cancel, isn't it? These will cancel that. What are you left with? You're left with negative cos squared theta divided by cos theta. Ne? Now cos squared divided by cos theta, that means you will have your final answer as negative cos theta. All right, quite a beautiful question, right? Are we okay here? Any question?
How many marks is the question?
This one is around 4 marks, say. How do they usually mark, right? They would mark you for actually identifying that this is sine. They would mark you for identifying this, and then also they would mark you here, and then your final answer. But then also, I think it was just that I cut off the mark allocation. It could be 5 or 4, right? Because even this one here deserves a very, very nice mark there. So yeah, 5 or 4. Yes, Tabo?
Is there a step where you can skip and go to the other step?
Is there a step you can skip? I guess you can skip this one. You see here where you put 360, ne? It's not really necessary to put the 360. You can just simply say that is cos theta. From here, you can simply say it's cos theta. But I guess it goes along with this step. So, and then another thing, sine squared theta minus 1, you can actually write it as cos squared theta. You see, so you could have just said from here, you have cos squared theta divided by cos theta. It's negative cos squared theta, and then you will have negative cos theta as your answer. So if you are, I know there are high flyers, right, who are able to recognize these because they can just use this relationship really quick in their heads. But we also need to accommodate some of our students who need some time to actually process everything. So hence I'm saying, even the one here, whenever they see the one, they're allowed to put that. Right, any other question? Yes, Neo?
No, sir. Can you please remind me that when changing the trig ratio, won't we first consider the sign of cos in that quadrant?
Nice. Okay. That's a beautiful question, right? To say when you are changing the, I think it was I get we had sine cos 90 degrees minus theta, right? When we are changing this to sine theta, do we consider to say that 90 degrees minus theta is in this quadrant? Do we consider that? And get well, you actually have to consider that. However, I usually say you only consider it when you are dealing with 90 plus, but when you are dealing with 90 minus, they will simply change and be positive. Okay, so what I'm saying is that if you have sine 90 degrees minus theta, this will simply change to cos theta, and it will be positive because 90 minus is in the first quadrant. And then if you have cos 90 degrees minus theta, that will change to what? To sine theta, and it will be positive since it is in the what? The first quadrant. Now, what if now we have sine into 90 degrees plus theta? What about if we have a situation like that? Well, that is no problem. Usually we consider 90 degrees plus theta to actually be in this quadrant here, in the second quadrant. We actually consider it to be there, right? What I usually do is that I don't want you to maybe cram, right? To cram that 90 plus will be minus or it will be plus. I just want you to remember that if you have sine 90 plus, you're just going to change it to cos theta. And then if you have cos 90 degrees plus, you're just simply going to change it to sine theta. Ne? Now, in terms of the sign, remember I said when you have plus, it could be negative. So in terms of the sign, you are going to verify it and be 100% sure. What do I mean by that? You take your calculator, ne? Then you are simply going to type in or to punch in sine 90 plus theta. So you're going to write sine, and then you open bracket. Oh, this bracket is open already. You say 90 plus. I personally like to use 20 degrees all the time for theta. So you put 20 degrees in there. Then just check the answer. Don't check, don't focus on what the answer is to say it's 0.9, what. No. Focus on the sign. Is it positive or negative? The answer you get is positive, so it means I must put positive here. Then you go ahead and do the same thing for cos. You say 90 and then just use 20. Just say plus 20. You see that the answer is negative, so you're gonna put negative there. So I do not know, right, how you I know some people actually say this. Some people say, oh, but since cos is negative in this quadrant, right, the answer will be negative. That is still okay, right? But I'm just saying sometimes you can be under pressure and forget to say which one is negative. So you're simply going to put that in your calculator, use 20 degrees, then you're going to get the sign, whether it's positive or negative. Is that clear? I think it was Neo. Is that clear?
Yes, sir. Thank you. I confused the quadrants. Thank you, sir.
Okay, no problem then, no problem. All right. So let's look at the second question, good people, right? Now that at least we got a reminder of that, try this one, right? Or rather, I'm going to walk you through this one. Just to show you what to do, real quick. What do we do, right? So we have tan 180 degrees minus theta. I cannot emphasize enough that you must always have your cast diagram. So you draw your cast diagram somewhere there, and then you can even draw it at the back of your answer sheet just to always have it. So that should be what? Allow sweet treatment for lighting. Alright, so it should be like this, and then you can have your 0 degrees there, or 360, and then your 90 degrees there, 180 degrees, and then 270. Then you're going to put plus here, then you're going to put minus there. So you can do this minus and then plus, okay? Then you will know that, oh, it is minus theta is plus theta, okay? Then here you're going to put plus here, you're going to put minus here. Then you will know that it is 360 minus theta is 360 plus theta on top, okay? But you can write them properly, whichever way you were taught at school, good people, right? I'm not trying to remove that. You can still use that. So now we have tan 180 degrees minus theta. Focus in the bracket first, right? 180 minus is in which quadrant? Anyone to tell us real quick? 180 minus.
That's the second quadrant.
That is the second quadrant, 180 minus theta. Now we then say, is tan positive or negative in that quadrant? we can see that this is the home of sine. It's only sine which is positive here, the rest are negative. So that tells us that the tan must be what? Must also be negative. Then we say tan theta. Good people, then you use brackets. Common errors that students do, ne? They write this thing as negative tan 180 degrees, number one. This is an error because we shouldn't say 180, we should say theta. Get another common error that I've realized that some people say negative tan and then inside they put negative theta there. They take this with its sign. Good people, it should be tan of the angle alone. You understand me? Like this. So let's not make those mistakes there. Right, then this one we have cos negative theta, right? Remember I said to you, you don't have to put 360, but you can still put it, right? Like I said, I don't want to remove what you were taught. It's still okay, right? But you should just recognize that a negative angle means you are in the fourth quadrant. And in the fourth quadrant, it's only cos which is positive. So we should put what there? We should put cos theta. All right. And then what about 390 degrees? Well, 390 degrees, can we agree that it's an angle that is bigger than 360? So because of that, what do? You simply take your calculator, good people. You say 390 minus 360. It gives you what? 30. So you are simply going to write sine. 30 degrees. Okay? Do not worry much about that. As long as you have subtracted and you got an angle that is less than 360, that is the one you write there. Then we have divided by cos 300, right? Now when you have angles like 300, 150, 250, what do you do with the angles? It's very, very easy, good people, okay? You are going to say 300. Remember, we move in an anti-clockwise manner, right? You're going to say 300 is in which quadrant? Is it between 90 and 0? No. Is it between 90 and 180? No. Is it between 180 and 270? No. Is it between 270 and 360? Yes.
Yes.
Perfect. Once you say yes, right, then you say, oh, since it is in here, let's remember that in there is 360 degrees minus theta, isn't it? I get it. It's 360 minus theta in this quadrant. Then you are going to perfect. Then you are simply going to take this angle, then you are going to equate by the angle. I know, I'll show you a much faster method. But usually I think of those, my struggling learners, right? So I then say to them, no, you can even equate if you feel like, you might make a mistake. Just say 360 minus theta and equate to the angle you want to reduce, okay? Then now you just solve for theta there. Now you would take 360 to the other side, right? To say minus 300 degrees, and then just take these to the right hand side so that you have theta. So in that way you will have 60 degrees as your what? As your theta. Good people, now that you got 60 degrees as your theta, which means that is the angle here. It means theta is 60. So you must write that as cos 360 degrees minus 60 degrees. Okay. Another way would be to say, okay, the moment you see 300 and then you identify that it is in this quadrant of 360 minus, you ask yourself, what should I subtract by to get 300? So usually you can get it by just saying 360 minus your 300, and then it gets a bit, interesting in terms of the signs, right? So you must be careful to say all the time, you try to say the bigger number minus the smaller number so that you don't get confused with the signs, right? But otherwise, it's just a matter of asking yourself, what do I subtract with to get 300? Okay, I hope that is clear. And then we have sine theta minus, right? Here we have cos 450, right? Remember, these are angles bigger than 360. So you're simply going to go to your calculator, you say 450 minus 360. what do you get? You get 90 degrees. So you're gonna write it as 90 degrees there. Right, I hope that we're still...
You said what? You said what?
Oh.
Cos 450.
Yeah, you I get 450 is bigger than 360, right? So you are simply going to subtract that value which is bigger than 360. You're gonna subtract 360 from it. So you say 450 minus 360. You're going to get 90.
Okay.
Yes, you get 90 there. Great stuff. Then you write the answer there, okay? Instead of writing that angle that is big, you just simply write the answer. So now that you are here, right, we need to simplify, isn't it? Now the beauty of trigonometry is that if you have tan theta, you can express it in the form tan theta is equal to sine theta over what? Over cos theta. That's what we discovered in grade 10, right? So it means that you're going to write that as negative sine theta over cos theta, still in the brackets, good people, right? Then here you have cos theta, and then here you have sine 30, right? Remember, for 30, once you see the following angles, once you see 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. I need you to know that all of these, good people, they are actually special angles. They are special angles. But one might say, Alminer, but Mina was taught that special angles is 30, 45, and 60. I do not dispute that. That is very good. Okay, good people. However, you see these 0, 90, 180, 270, 360. They are actually these ones here. They are also included as part of being special angles. Why do I say that? For those specifically, 0, 360, 90, 180, 270, the moment you get any ratio, sine, tan, or cos, which is consisting of that, you're simply going to put it in your calculator. You understand me? So what do I mean? For example, you have cos 90 here, again. It's one of the angles here, the corners, again. You simply put it in your calculator. There's no need of doing anything special. You just put it in your calculator. Alright? If I had cos 180 there, I would simply put it in my calculator, good people. You understand me? Then these three, specifically, you're going to use the triangles. I know there is actually also a Venn diagram, but you're going to use your... I prefer the triangles because we have a special way of remembering them. Ne? So this is what you would do. I feel like the triangles are more easy to remember than the Venn diagram. You can simply then say 45 degrees and then you say 45 degrees. Ne? How do you remember now? You just say, remember that the sides will be 1, 1. Again, what is 1 plus 1? 1 plus 1 is 2. I'm thinking even a grade 1 learner can tell you that. But don't forget to put the square root sign. Then that is your first triangle. Then the second triangle, remember. It's like this. You're going to have 1, 2, 3. As if you are counting 1, 2, 3. And then here on 3, you just put a root sign. And because you have a 3 here, it should remind you that here at the corner, the angle should be 30 degrees. Okay? At the corner there, the angle should be 30 degrees. Then automatically this one will be 60 degrees. Alright? So those are our triangles that we use. Speaking of which, we have sine 30 there. So 30 degrees is which one? This is 30 degrees. And sine, according to SOHCAHTOA, we say is the opposite side over the hypotenuse. Remember, the hypotenuse is the longest side, right? Opposite over hypotenuse. So that means sine 30, we can write it as 1 over 2. Right. We are doing very well, good people. We are finishing, in fact. So we say, now, cos 360 minus 60. Let's remember that 360 minus is in this quadrant, and in that quadrant, cos is positive. So we simply say we have cos 60 there. And then you have sine theta there. Minus. Now you have cos 90, right? Like I told you, good people, if you see 0, 90, 180, 270, 360, run to your calculator. Okay, so you say cos 90, and then you just write 0 there. You get your mark. Someone actually told me that you can actually do maths with only a calculator and still pass, even though it won't be just too much of a pass, but you will still pass. All right, so this is what we have so far. Then what will happen, good people? This is a numerator, this is a denominator. They definitely do what? They cancel each other. Then we are left with negative theta times half, which is what? Remember, you can say that is negative sine theta divided by 2. Still I put in brackets. Okay, remember, negative theta times 1 is going to be negative sine theta. Yeah? Negative sine theta times 1 is negative sine theta. And then 1, remember at the bottom, when you are cancelling, good people, doesn't mean you are left with 0. You're actually left with 1. So you say this 1 that is left times 2, you're going to get 2 there. All right. And then cos 60, it's a special angle, good people. We run to our triangles, right? We run to our triangles and then we say, now I'm focusing on 60. Now, since it's cos, it says adjacent. Okay. If you want to remember the adjacent side, especially if it's like this, it's like if you were somewhere here, ne? And then looking straight, the side you are looking straight at is the opposite side. The side you are stepping on is the adjacent side, and then your hypotenuse will always be the longest side. That's how you can try to remember there. Okay, so adjacent side to 60 is 1 because cos is adjacent over hypotenuse, right? So you say you have 1 over 2, okay? Then you say sine theta there. Minus 0, that just means you have 0. So actually, you have negative sine theta over 2 all divided by sine theta over 2. So what happens? This one cancels that one, so you are left with negative 1. Good people, it doesn't mean that we'll always get negative 1. It's just a coincidence, okay? However, that is how we solve that. Any question? Yes, Tabo, I see you raised your hand. Oh.
Sorry, say it's a mistake.
No problem at all. Are you following though?
Yes.
Beautiful stuff. Okay, so you see these triangles, good people. I think you might need to have them somewhere because we're still going to need to use them in our CAS diagram. So let's see if right, have some time to work on this one now. Oh wait, you know, when you have done trigonometry so many times, good people, when the moment you see a question, you already see the answer. That's the problem of knowing trig too much. But it's not a problem as such. Try to strive for that, okay? So now when you see this one, good people, the fact that we have cos and cos, right? The fact that we have sine and sine, we have cos and cos, we have sine and cos, right? Those things there, they should remind us of what? They should remind us of our compound angles. But unfortunately, my time has run out. So I hope you have it somewhere, right? I'll send you another link, you join, then we can continue with this. Then you sleep, right? So just give me a few seconds to create another link. let me just try to share the screen here, right? And then we can look at that problem there. Feel free to give it a try, good people, right? Feel free to give it a try, and then we can look at it, right? Maybe we can just have 2 minutes for that, right? And then we can look at it. Feel free to give it a try. Then in 2 minutes time we can take a look at that, right? Yes, Divine. Okay.
Let's do a test.
A test.
Test.
Oh, that diagram. Okay, okay. Um, let's have this diagram here. Right. So 0 degrees or 360 degrees there. You have 90 degrees, 180 degrees, 270 and 360. Yes, Divine. Okay. Um, let's then try it, right? So good people, since we have cos 10 there and then we have cos 340, right? First of all, we need to apply reduction, okay, which means that we need to reduce the angles. Remember, the cast diagram is used to reduce the angles, right? So we have 340 there, right? We can actually reduce that angle. We want to get acute angles, angles that are between 0 and 90. Now, cos 10 is already an acute angle, so it's fine. We can leave it like that. And then cos 340, you ask yourself, 340 is in which quadrant? It is in this one, right? Cos 340 is between 270 and 360, right? Which means we are in the fourth quadrant. Now in that quadrant, remember, we have 360 degrees minus theta. And get? Remember, in here it is 360 degrees minus theta. So you're going to ask yourself, what number should I subtract 360 by so that I get 340? Which number is that? I should say 360 minus what to get 340?
360 minus 20.
Great stuff. 360 degrees minus 20, right? So it means you will say, we can write that as cos into 360 degrees minus 20 degrees. Nice. And then here we have sine 190, right? 190 is not an acute angle because it is bigger than 90. We need to reduce so that we get acute angles, angles that are between 0 and 90. That is the purpose of these reduction formulas here. Okay, so 190, it is in which quadrant? 190 is between 90 and 180, isn't it? So since it's between 90 and 180,
No, it's wrong. It's wrong.
oh, it's not between 190, is it 90 and 180? Oh, it's between 180 and 270. Nice stuff. Thank you so much for that. All right, so that means that we have okay, 190 is there, and in this quadrant, remember, it's 180 degrees plus what? Plus theta. So you will ask yourself a simple question to say, what must I add 180 to 180 degrees to get 190, right? If we can say 180 plus 10, we'll get 190, right? Then another way of finding that, we can just say 190 minus 180, or you do the longer method that I showed you to say, you can say 180 degrees plus theta is equal to 190 degrees. You know, if you are unsure, so that you solve for that theta, for that angle, you must add to 180. Okay, so it means now we'll write this as 180 degrees plus 10 degrees, right? And then this is a negative angle, good people. Remember, it's a negative angle, and we said the negative angles are in the fourth quadrant. So sine negative 20 degrees in the fourth quadrant is sine positive or negative. It is what? Negative, right? So you say you have negative sine 20 degrees there. And then at the bottom here we have an acute angle. 80 degrees is an acute angle. We can leave it like that. 20 degrees is an acute angle. We can leave it like that. However, we have 100 degrees now. Where is 100 degrees? It's between 90 and 180, right? And we know that in here it's 180 degrees minus theta. So you ask yourself, what must we subtract 180 degrees with so that we get 100, right? So I believe that should be 180 degrees minus 80 degrees. I get nice stuff. And then cos 70 degrees. Is this fine? Any question? We can move. What's next from there? So we have to just apply then to say what is happening there, right? For example, cos 10, we can just simply write it as it is, right? And then cos 360 minus, remember 360 minus is in the fourth quadrant where cos is positive. So you can say you have cos 20 degrees there. and then sine 180 plus 10. Now 180 plus is in here. Is sine positive or negative? Sine is negative in there because this is a home of 10. So you say you have negative outside, but inside again you're going to have negative sine what? Negative sine 10 degrees. Okay, and then you have negative sine 20 degrees there. Okay, then you divide by sine 80 degrees multiply by cos 20 degrees plus now cos 180 minus is in it is in here, right? Is cos positive or negative in there? Our cos is negative, right? So we have negative cos 80 degrees. We multiply by cos 70 degrees there. The rest is a bit of what? A simplification in terms of the signs, right? So we can then say we have cos 10 degrees, cos 20 degrees, now minus negative times negative gives us positive, right? So it means we're going to have positive sine 10 degrees multiplied by sine 20 degrees, right? Then here we have sine 80 degrees times cos 20 degrees, and then minus, cos positive times negative is negative, right? Minus cos 80 degrees times cos 70 degrees. Great stuff. Reaching this far means, good people, you worked very hard, eh? Not many people not many people can reach there. So we are doing very well, but however, we need to do what we call we need to add the last piece of the cake there, right? We need to make sure that we finish off now. When you finish off, I want you to take a look at the following, because now you have cos times cos, sine sine. That should actually remind you of your compound angle formulas, right? And your compound angle formulas, good people, remember you have the ones for sine, you have the one for cos, right? Do we know those formulas by heart, or we need to go to the formula sheet? I know some of us need to go to the formula sheet. That is very much okay. However, if you have been having an interaction with ladies and having an interaction with gentlemen out there, I think you can get these formulas by heart. You know, good people, you are grade 12s, you are doing life science, you are doing life orientation. So I think what I'm going to say here, good people, you can relate it to one of those subjects, right? And try to use it if possible, right? So the formulas for cos, right? Let's say you wanted cos, so maybe I can have them in yellow. Let's say you wanted to have cos 1, cos A, let's say plus B, ne? Now, because remember, at your formula sheet, at the back there, at the back there, they just write them like this. They just write them as plus or minus B, and then they give you there, they say plus or minus. So now you must be able to know where is the plus, where is the minus, and so maybe to assist you a bit there, we could say A, we can start with A plus B, ne? Think of cos as a lady, right? You know, cos as a lady now. Ladies like to stay alone. That is why they like to share their own things alone. You know, ladies, they can share makeup, they can share a lot of things, lip gloss, they can share some heels, right? You know, ladies, they know what I'm talking about. So cos is like a lady, she wants to share with her friend, so that is why you'll have cos A, and then you'll have also cos B. Good stuff. However, good people, I think through the interaction with ladies, you can understand that they have mood swings. They change a lot, those people, right? They change a lot. No offense, but they do change a lot. So the plus will change to what? To minus there. and then you'll have the gentlemen sitting together and then sharing the as only gentlemen. Same thing with minus, right? You would just simply say you have a minus b, and then you would say cos a, then you say cos b. Remember they change, right? So it means here you should have plus, and then have sine a, and then have sine b. Right, you know these things, good people. And then now for sine, right? Sine, you can think of sine as a gentleman, right? Gentlemen like to share, so you can find sine a will be sharing with cos for that other angle. And men don't change, good people. We are very good people, so we still have plus. And then after that we then say, since I started with sine, I took a, right? We even say no, you can even take my car for today. So it means here we can even start with cos a and then end up with sine b. That's men for you, right? And then you have here sine a minus b, right? It's a man, right? So he will take the a. He does not mind to share that with a lady, to share that bracket with a lady. And we can even say, and we don't change, right? Then we can even say, yeah, you can even take that a, you know, when you ordered something there and then she wants also what you ordered, but she's the one who chose what she ordered. But then I know you don't understand these, good people. A time will come, right? So here we have cos 10, cos 20, and then we're just going to link those formulas to that. So when we link them, good people, we say we have 10 degrees and 20 degrees. Here, check, you have A, B everywhere. So we have 10 degrees, 20 degrees. That is okay. We are happy about that. Here you also have 10 degrees and 20 degrees. Good people, we are definitely happy about that. Then lastly, what you just need to do now is to tick, or rather to identify which one is it. You have cos, which definitely means that you're talking about a lady. And then here you have minus. So if you have minus here, it means that for the condensed compound formula, it should be plus, right? So we're simply going to say, therefore, we're going to have cos 10 degrees plus 20 degrees there. Then you divide. Now at the bottom, it's a bit not that nice. You know why I'm saying that? You have 80 degrees, 20 degrees. That's okay. We expect another 80 degrees and 20. But we find 70 here. So definitely we are not happy about that. We have to fix the bottom part first, which creates a lot of work for us, very much unnecessarily so. However, we can do it, right? So you say, okay, we have sine 80 degrees times cos 20 degrees minus cos 80 degrees. Now, the cos 70, you're going to try and reduce it, right? By writing it as what? By writing it as cos 90 degrees. What must you subtract to get 70? You must subtract 20 degrees there. Right? Then what is going to happen? Now you're going to have cos 30 degrees, right? All divided by sine 80 degrees cos 20 degrees minus cos 80 degrees. And then remember, once it says 90 minus, the cos will change to sine. So you will have sine what? Sine 20 degrees there. Then it's okay because now we have 80, 20, 80, 20. Now we can go here and say which one does it link with. Since it's sine sharing with a lady, we definitely know that we're talking about sine. And since here it's minus, remember men don't change. So it means that you're gonna have cos 30 degrees divided by sine the first angle 80, then minus 20 degrees. Nice stuff. Which means you're going to have cos 30 degrees divided by what? What is 80 minus 20? That is simply 60 degrees. Good people, the answer here is going to be 1. However, you don't just write 1. I know our curriculum is something else. They want you to show. So we are going to try and show that. Thank you. But how do I know it's 1? Good people, once we have sine and cos, ne? And then the angles that they have, they add to 90. The answer will always be 1. Let me give you an example. If you have 70 degrees here, ne? And then here you have 20 degrees, the answer is going to be 1. If you have 20 degrees on top and then 70 on the bottom, the answer is going to be 1. If you have 50 degrees here and then you're 40 degrees, the fact that 50 plus 40 is 90, the answer is going to be 1. But it is only true if it is sine and cos. Not that when you have sine 50 degrees and then at the bottom you have sine 40 degrees, that the answer is going to be 1. No, good people, that is not true. That is not true. It's only when you have different ratios, sine and cos, only to be specific. And if the angles between them add to 90. So here they add to 90, good people. 30 plus 60 add to 90, and you have cos and sine. The answer should be 1. However, we must show it, right, by reducing maybe any of the angles. I'm going to reduce the top part. So I'm going to write that 30 degrees as 90 degrees minus what? Minus 60 degrees. Then here you have sine 60 degrees. Now that it's 90 minus, remember cos will change to sine. So you will have sine 60 degrees divided by what? By sine 60 degrees. So your final answer is 1. Alright, I hope that was, I know it was a bit long, sorry for that. But we're trying to give you all the tools necessary to master trigonometry. It's a very, very nice part of paper 2 that we must ace very nicely. Okay, any question from there? No question. Okay, no problem then. So good people, from me, that's all I had for you today, good people, right? You can write this one down, maybe just do it there when you have time. You can just send me the solution if you are able to do that. Let me see if I have it here. Okay, but this one is quite an extremely easy one. Yeah, no, let's say this one and something else, something more powerful. Let's see. Aha, I like this one. Yeah. Please write this one for me, good people. But it's too easy. It's too easy. Yeah, but it's fine. Just write for me 5.3.1 and okay, we already did that one. And let's see. Wait. Yeah. Okay, yeah. They should be fine, these ones, They should be fine. They should at least try to jog your memory there. I know that they are not challenging. So this one and that one, good people, you can quickly write them down, or rather, in fact, I'll just send a screenshot of this into the group. Then from me today, good people, let me not take much of your time. I hope you learned something. Best of luck.